Hi dear students, welcome to my class. Let me switch off the fan. Okay, I hope you are enjoying my videos and you can put your suggestions, doubts, comments to the YouTube link and I will find that suggestions and doubts and I will modify my classes and videos as per your suggestion. And I have one request to you. You have to watch the videos seriously. Whenever you watch, please keep a notebook and pen with you. And you write down the contents. If you keep the videos procrastinate the videos next day, please remember, videos will keep on sharing and it will pile up and it will become a burden for you. Please remember, time management is the key of success. Okay, welcome to the class. Today I go to the third video for chemical kinetics. Today my discussion topic is factors affecting rate of reactions. Okay, we can discuss what are the factors which affect the rate of reactions. These are the four important factors: concentration, pressure, temperature and catalyst. Pressure and concentration can be discussed and understood together because pressure is another version of concentration which can be applied only when the reactants are gaseous. Fine. Therefore, when gaseous reactants comes, instead of concentration term, you can use the pressure term. Fine. Therefore, it's not a complicated one. Both are discussed, both could be understood together. Temperature is another one we will discuss in detail. Catalyst is another one we will discuss in detail. Now we can go to the topics: effect of pressure, fine, effect of concentration and pressure. The effect of concentration on rate of reaction has been beautifully articulated, beautifully defined by law of mass action. That has been explained by law of mass action. Do you remember this? I think you have learned the law of mass action in chemical equilibrium chapter. If you don't remember, please refer it and get the idea. Anyway, I will discuss it in short, in the way we can understand the effect of concentration. The law of mass action says that the rate of reaction is directly proportional to product of concentration of reactants. Listen, product of concentration of reactants. The concentration of reactants are called active masses. This is very important. Active masses. Active masses means the active concentration which take part in the reactions. What is that meaning? Suppose you take 1 mole of the reactant. 1 mole of the reactant. Only 0.9 mole of the reactant is actively involved in the reaction. 0.1 mole is inactive. Therefore, when you take the product of concentration of reactants, you don't take the 0.1 mole completely. Instead, you take 0.1 mole, 0.9 mole, because that is actively involved in the reaction. That's the meaning of active mass. We will discuss this effect of active mass in detail in higher classes. But you please keep this word in your mind. That's very important. Therefore, rate of reaction is directly proportional to product of concentration of reactants. Not only that, coefficient of each coefficients are raised as power. Okay, what is this? What is the meaning? Suppose you have a reaction AA plus BP gives CC plus DB. What is the rate of this reaction? Rate is equal to, rate directly proportional to, this is law of mass action, concentration of A and B, product of concentration of reactants. Not only that, the coefficient is raised as a power. Please careful. I have written the coefficient x and y. This is the law of mass action. Mass action. Yes, this is the law of mass action. I will explain you why I put x and y instead of A and B. Now, this proportionality constant has been removed by a constant that is K. Why? Fine? Yes. When you express the rate with a rate constant, this expression is called the rate law expression. This expression is called rate law expression of this reaction. If someone asks you, what is a rate law expression of a reaction? That reaction should be expressed like this, where R is called the rate of the reaction. Rate of the reaction. In previous video, we have a detailed explanation of how to express rate of a reaction. That can be applied here. Now, what is R? R is the rate of reaction. What is K? What is K? Tell me. K is called the rate constant or velocity constant. Velocity constant. I use some simple writing. What is A and B? And B called concentration of reactants or active masses of reactants. Yes. What is X? What is Y? What is X? What is Y? Please carefully understand what is X, what is Y. You don't say it's a coefficient. Don't say. It has a different meaning. Where X is called order of reactant A. Y is called order of reactant B. What is X? X is order of reactant A. What is Y? Order of reactant B. A new term was introduced here. New term is introduced. Order of reactant A. What is X plus Y? Dear student, please remember what is X plus Y? Order of reaction. This reaction. Now, I will tell you one point. X and Y may or may not be equal to A and B. May not be equal to small letter A and B. Very, very important concept I am going to explain here. X is order of reactant A. Y is order of reactant B. X plus Y is order of reaction. Do you remember in the previous video, I had told you that each reactant and each product has individual rate of change. Similarly, each reactant has its own order, and there is a specific order for reaction also. Similarly, we have a specific rate of a reaction. Reactants have individual rate, similarly reaction has its own rate. Similarly, likely, reactants have its own order and reaction has its own order. What is a reaction order? Sum of orders of reactants. Fine. This is the order, and what is K? K is called the rate constants. First we can explain what is rate constant. Just an explanation of rate constant. We can explain for first rate constant. Rate constant. Okay. What is rate constant K? Consider a rate law expression. K is equal to A raised to A, B raised to B. What is the rate constant? What is the mathematical way of expressing this constant? You make these things unity. Unity. How can you make these things unity? That is, A is equal to 1 mole per liter, B is equal to 1 mole per liter. Therefore, R is equal to K into 1. 1 into 1, that is K. Therefore, what is rate constant? It is the rate of reaction when concentrations of reactants are unity. We will discuss more about the rate constant. Just I introduce what is a rate constant. When there is a question, what is a rate constant? Please write this definition. It is the rate of reaction when concentrations of reactants are unity. Fine. Now we can discuss what is order of the reaction. What is the order of the reaction? Okay. Order of the reaction. How do you define order of the reaction? Okay. Tell me, what is the definition of order of the reaction? It is the, please carefully listen the definition. It is the number of molecules of reactants, whose concentration determine the rate of the reaction. It is the number of molecules of the reactants whose concentration determine the rate of the reaction. Listen. It is a number of molecules of the reactants. Which reactants? Whose concentration determine rate of the reaction. Therefore, if you take a reaction A plus B gives product, what is the order of A? Order of A tells you the number of molecules of air which determine the rate of the reaction. If the presence of air does not determine the rate of the reaction, you can say its order is 0. Carefully listen. If the number of molecules of air does not depend on the rate of a reaction, its order is 0. Fine. We will discuss the 0 order in detail, but please listen my definition. Number of molecules of reactant whose concentration determines rate of reaction. Mathematically, order of reaction is equal to sum of orders of each reactants. Now, what is the order of reactant? Order of reactants is equal to, or is the powers raised in rate law expression. That is, R is equal to K into A raised to X P raised to L. It is the powers raised above each reactant in a rate law expression. And their sum is the rate of reaction. But they are mathematics. But really, what is the order of the reaction? Is the number of molecules of reactants whose concentration determine the rate of the reaction. Now there is another word, molecularity. What is molecularity of the reaction? Molecularity of reaction. Could you follow me? Is it clear? If any doubts, you can type me, you can comment that, and I will attend. What is the molecularity of the reaction? It is the, I will tell you the direct definition. It is the minimum number of molecules or atoms or ions, minimum number of molecules, atoms or ions of the reactants required for the reaction to occur and equal to coefficient of reactants in a balanced chemical equation. It is a complete definition. Don't feel it is a lengthy and boring. Don't feel it is lengthy. I have taken this definition because it includes all the aspects. Fine. It is a minimum number of molecules or atoms or ions of the reactants required for the reaction to occur and equal to coefficient of reactants in a balanced chemical equation. Therefore, molecularity can directly pick up from the coefficients of a balanced equation. But you cannot pick order from the coefficients. You may fail. Fine? Order cannot be done like that. But molecularity can be done. Fine? Now suppose there is a question, differentiate between order and molecularity. It's a usual question, order and molecularity. It's a usual question. Okay, 2 mark question or 1 mark question, differentiate between order and molecularity. The first is, order is an experimental quantity. Experimental quantity. It's an experimental quantity. This is a theoretical one. Theoretical quantity. Okay. Order can change when experimental setup changes. Here, molecularity cannot change when experimental setup changes. Order is an experimental quantity. When experimental setup changes, order changes. What does it mean? I said to you, order is the number of molecules whose concentration determine the rate of reaction. Suppose you take A and B reactants and gives the products. You want to know whether the reaction rate increases when concentration of A increases. Fine. This could be known. This could be understood only when you do the experiment. You cannot understand simply by looking. Could you do that? No. Whether rate depends upon A or B, number of molecules of A or B, it is only understood when you do the experiment. That is why we say that order is an experimental quantity. But in the case of molecularity, you don't need that. If you know the balancing of a chemical equation, after balancing that, you will get the molecularity. Fine? That is why we say that order is an experimental quantity. Third is, order can be fraction, negative, positive, even zero. Order of a reaction happens, but order can be zero. But it can be only integer except zero. It cannot be zero, it cannot be fraction, it cannot be negative. That is why when we balance a chemical equation, if there is fraction comes, immediately we will remove that fraction by multiplying with this suitable integer. You remember that? Yes, because molecularity or coefficient cannot be scientifically cannot be fraction. That is unscientific. That is nonsense. Fine. Now the fourth point is, if there is a 2 mark questions, you manage a fourth point. I will tell you. I have noticed somewhere the fourth point. Yes. Okay, that's all. These are the points. Experimental quantity or can change. Yes, fine. Now we can examples for different order of reactions. Examples of different orders of reaction. Examples of different order. Order reaction. Different order reaction. Okay? Are you okay, students? Yes. First, zero order reaction. zero order reaction. Mainly heterogeneous catalysis reactions are zero order. Don't think that all heterogeneous are zero order, but mainly heterogeneous catalysis reactions are zero order. Some example: decomposition of NH3 in the presence of platinum, N2 plus 3H2. Another one, 2HI gold catalyst, H2 plus I2. Second is photochemical reactions. Photochemical reaction, that is H2 plus Cl2 H2. Please remember, don't think that all photochemical reactions are zero order. That's wrong. Order can be understood from rate law expression. I suggest you some example which has been asked in different examinations and given in different textbooks. Okay? When I say photochemical reaction and heterogeneous catalysis reaction, you never generalize that. Please careful with that. Now, another one is first order reactions. We can have some example for first order reaction. First order reaction. One of the most common first order reaction is, example is radioactive reaction. Radioactive reactions. Okay. Radiocarbon dating based on first order reaction mechanism. Second is normally decomposition reactions. Example, H2O2 decomposed, H2O plus O2. N2O4 decomposed, NO2 plus O2 like that. Okay, 2NO2 plus O2 like that. These are some common examples for first order reaction. Now a fractional order reaction. One example for fractional order reaction. Decomposition of this particular acetaldehyde CH4 plus CO. Its order is, rate law expression is K into CH3 CHO 3 by 2, 1.5. Because when you do the experiments and get the rate law expression, you will get this value 3 by 2. That's a fractional order. Now I have said to you, when concentration or experimental conditions changes, order changes. There is one example, beautiful example. Isomerization. You will get these products. Propene. It is a second order at low pressure of cyclopropane. When cyclopropane pressure is low, it is a second order. But it is first order at high pressure of cyclopropane. This is one of the evidence when experimental conditions changes, order will be changed. Fine. I challenge you to get more examples for different order of reactions. Is it okay? Okay, you collect more examples for different order of reactions. And you never, when you get any example, never generalize that. Because order is an experimental quantity, it could be obtained from rate law expressions. Okay. Now, next is order of reaction and rate of reaction. It is one of the important topics here where there are many scopes for numericals. When you take any competitive examination or university examination or board examinations, you will see a lot of numericals from these topics. We can do one question here. I have the data. Consider a reaction. Consider a reaction A plus B gives products. Concentration of A, concentration of B, and rate of reaction. Rate of reaction. Concentration of A is given 0.025, 0.05, 0.025, 0.025. This is mole per liter. Mole liter is minus 1. Right, mole liter is minus 1. Second is unit. Here 0.017, 0.017, 0.034, 0.017, right? 0.1, 0.8, 0.1, 0.2. What is the order of A, B, and reaction? What is the rate law expression? What is the rate law expression of this reaction? Right? This is a question. Consider a reaction A plus B gives P. Concentration of A and B in different occasions are given. 0.025, 0.05, 0.025, 0.025. Concentration of B is 0.017, 0.017, 0.034, 0.017. When these are the concentration of A and B, or rate is 0.1, here 0.8, 0.1, 0.1. How will you solve the questions? When you look at the reaction, the coefficients are 1. Could you say that this coefficient, could you take that coefficient as order? No. Here is the meaning of experimental quantity. Okay. Suppose I am the experimenter. I did an experiment with this concentration and this concentration. I got the rate. Now I change the concentration of A here. But I keep the concentration of B constant, I got this rate. Therefore, I can understand that rate depends upon the A, concentration of A. This is a meaning, order could be calculated, order can be calculated. Order is calculated with experiments. Now, I will tell you a simple trick to solve this question. Simple trick. Please practice that trick. You know how? First, you find out the order of any one reactant, suppose A. For that, you take a pair of data where B is constant. Fine? B is constant. Therefore, you can take first two pair because B is constant. Therefore, I want to determine the order of A. So that I take this pair, B is constant. Now what I am going to do, I just do a mind calculation. How many times here changed? 2 times. A has been changed 2 times, doubled. Okay, I neglect here. Then with respect to this change, how many times rate changed? 8 times. Now I have a relation change in concentration times of A I make a relation. Raised to x, x is the order of A, fine, x is order, is equal to change in rate times, okay, change in concentration times of A is equal to change in rate times. I make a relation, fine, because when concentration changes, rate also changes. Therefore, based on this simple trick, how many times concentration of A changes? 2 times. Therefore, 2 raised to x is equal to how many times rate of reaction changed? 8 times. Therefore, I go to this type of a mathematics. Make this 8 into a factor with respect to 2. How is possible? 2 raised to 3. Therefore, x is equal to 3. Very simple. Very simple. What is order of x? Sorry, what is order of A? 3. It's a mind calculation. Once you practice it, you do that mind. Okay? Okay, therefore order of A is 3. Order of A is 3. Now we can go to B. For B, what shall you select? What shall you do? Do where concentration of A is constant but B is varied. B is varied. Here concentration of A is constant, but when corresponding pair B is also constant. Don't take. But you take this. Okay? What is, how many times? 2 times. What is the rate? Rate change? Tell me. Rate change. Tell me, this one. I am talking about this one. 0 times. Therefore, in the case of B, 2 raised to y, change in concentration times of B, that is 2 times, is equal to, what is the change in concentration of times? No change. No change. Fine. Okay, that is 1 times. 1 times. No change means 1 times. How is possible? This is possible when you have 2 raised to 0. Therefore, y is equal to 0. Y is equal to 0. Therefore, very careful. It's a mind calculation. You don't want to do this type of calculation. If the concentration of any reactant changes, but correspondingly rate is not changing, blindly answer. Without calculation, you answer that. Its order is 0. Once again, if concentration of any reactant changing, but correspondingly rate is not changing, its order can be 0. Is it okay? Therefore, please remember this trick in your mind. Please remember this trick in your mind. Fine. I think you are okay with this concept, and I give you last topics. Last topic with order of reaction. This is order of multi-step reaction. Multi-step reaction. Suppose a reaction happens in more than 1 steps. It is quite common in organic chemistry. Because in organic chemistry, you will not get directly the products. First you will get the intermediates. That intermediates reacts with another species and you will get the products. For example, I will tell you one example. CH3, CH double bond CH2 plus HBr. What is the mechanism of this reaction? The step 1 is CH3, CH double bond CH2 plus H plus gives CH3, CH plus CH3. This is the Markovnikov's products. Step 2, CH3, CH plus CH3 plus Br minus gives CH3, CHBr, CH3. And you will say this is the slow step, this is the fast step. Therefore, in this reaction, A plus B gives C, slow, C plus D gives P, fast. What is the order of this reaction? Order of the reaction. Order of the reaction is equal to order of slowest step reaction. Order of the slowest step of the reaction. Now I will ask you one question. What is the meaning of slowest step? What is the meaning of slowest step? Is it a step which will continue even the reaction is finished? No. Slowest step is the step which needs more activation energy. Which needs more activation energy. When you do an energy profile diagram of this reaction, suppose you do an energy profile diagram of the reaction, energy, A plus B, this is C, okay, this is P. This is activation energy of this reaction and this is activation. Which is a higher activation energy? This has higher activation energy. That is why we said this is a slowest step. Therefore, please understand, slowest step is a step in a reaction which consumes, which needs, which requires highest activation energy. This is all about the order of the reaction. I think you have understood this video. If you have any doubts, please WhatsApp me or message me, we'll clear. Thank you for watching. Have a nice day. Thank you.